Welcome everyone. So I'll be talking more about data frames in this video, and I have leveraged some of my code from the previous data frames video. So let me quickly describe what is happening. First, I'm importing numpy as np, importing pandas as pd, and from the numpy.random library I'm importing randan. So I've provided a seed of 101 to my random generator. This is basically for if you copy the exact same code in your Jupyter notebook, then the random values that will be generated will be same in both yours and mine's notebooks. So then I've created a data frame where I feed in data as of 5,4 array of random values, and then I have given my row names as A B C D E and my column names as W X Y and Z. So if you look at the data frame, so you can see that my data frame consists of positive and negative numbers. So like in Python, where you can do 2 is smaller than 3 and that outputs a boolean which is true, you can do the same with data frames in Pandas. So if I put df smaller than 0, or let me put it greater than 0, so then wherever there are positive values, the boolean will be given as true, and wherever there are negative values, the boolean will be given as false according to this statement. So I can use this condition for conditional selection in a data frame. For example, if I pass this condition into my data frame, which is daf, then if I run this, I'll get another data frame where only the true values are present, and the false values, where the condition is false, are as null or nan. So this is not so common when you apply it to a entire data frame, but when you do this to a subset of a data frame, it will return you will return a subset of data where it was true. So for example, let me uh, choose the dfw column, which is the first column, and then let me put a condition over here, suppose greater than 0. So you can see that I've got true, false, true, false, false. So true, false, true, false, false. And then if I feed this into my entire data frame, dfw is greater than 0, then you can see that the rows B, D and E have been omitted from this as they contain null values. So you can also assign this to a variable to make that variable a data frame, and then you can call additional operations on them. So here I'll just be selecting for example, just let me print out result first. So let me select the x column of result. So x, so that gives me this series. So this way you can use conditional selection to get more inside your data, and there's tons of ways that you can conditionally select your data, and it depends more on the data set that you have. So keep practicing this and you'll certainly be able to recognize what conditions you should be keeping in your data set. So now for multiple conditions, let's go back to df. So for multiple condition selections, first I'll show you the wrong way of doing it, or rookie mistake, so some might call it. So dfw is greater than 0, and dfy, that's actually small, so w and y is greater than 0. So we're finding only those rows and columns where the conditions both are true. So if I run this, I'll get an error. So unlike in Python, where you can check multiple conditions by using AND, so for I'll just put true and false away. True and true, that gives true. and true and false gives false. So this only is applicable to single conditions. So and doesn't actually work in data frames. So instead of this, we're going to be using ampersand sign. So if I run this now, you can see that I've got a data frame where both the numbers or the values in the W column and Y column are positive, which in this case is this and this. So you can use multiple condition selection like that. Now let's talk about resetting the index. So if I want to reset my index in the data frame, I can call the df.resetIndex function. So if I run this, you can see that the index has been resetted by numerical values, and my previous index have been assigned a new column and then have been kept as new column in the data frame. So, and one thing to keep in mind is that even if I call df right now, there will be no change over here. So you actually have to place the in-place parameter as true in order to change the data frame. So I'll not be doing that for now. So now let's try keeping new indexes in our data frame. So our data frame is df, and then if we're to put a new index, so for example new index equals to kec, then I'll explain what I'm doing. So kec, ioe, ku and pu and maybe tu, and then call a split function over here. So new index is a list, so this is just a convenient way of creating a list. So if I want to keep these values as my new index, I have to first create a new column in the data frame. For example, if I want to create a new column, let me call that column as collises, and then put as new index, put new index as the data in it. So now if I run df, it gives me a column of collises. So now if I want to set the index of this data frame to become as the collises name, so I can do that by using df.set_index function. So this will set the index as collises. So if I run this, there you go, the indexes are now kcioe and kupu So I actually meant to write tu over there, I just noticed that. So now let's talk about missing data in the pandas data frames. So many times when you are reading in data, you will have missing points in your data set. So missing points are basically null values like this over here. So let me show you how you can handle missing data. First, let me create a dictionary which I convert to a pandas data frame. So let me provide in value as 0, 1, and let me call the np.nan function over here to create a null value. Then let me create another key where I'll keep the data as, for example, 2, np.nan, np.nan, and then let me create another one, so another key, so c colon, let me provide it values, let it have all three values, for example. So now if I want to change this to a pandas data frame, I can just call pd.dataframe and then pass in the dictionary as the data. So now the data frame looks like this. So if I want to remove the rows or rows where the elements are null, so I can just call df drop na. So this will drop the null values from rows, and then it will drop the entire row, so not only the null values. So that gives me only 0. And then if I want to drop the null values from the column side, I can put as a parameter the axis. So by default it was 0, so rows had been selected. Now if I put access over here, the null values are dropped by columns, so A and B columns have been dropped and there's only C. So now if I want to keep a threshold for the number of null values that a row or a column should have in order to be dropped, I can use the trace parameter. So you can see over here this trace equals to none as a default. So if I keep the trace as 2 and I want to drop from the row, I don't actually have to put this, but for illustration, so if I run this, you can see that only the second row was dropped because there were 2 null values, and in the first row there was only 1 value, so our threshold is of 2, and thus the first row, I'm talking through the index number, so the first row is dropped. So then if you want to fill these null values in the data frame, you can call the df dot fill na function. So if you put in value, let me see if that's value. So if you want to put value as suppose field value, then the result will be like this. So it will change the null elements as the value. So this is useful if you don't want to lose much of your data, and instead of providing strings like this, what you can do is actually df.fill na, and let me provide the value of the df a columns mean. So if I provide this, then what is actually happening is it will take the mean of the A column, so that's whatever is over here, 0 and 1, and that's the mean is 0.5, so it will fill the rest of the data frame with 0.5. so you can use that in order to save your data. Another thing you can do is actually only change the null values in your A column so that you have more consistency. So if I run this, then I'll have that. So now if I run df, it's actually not in place, so in place equals true. So if I run that and I run that, you can see that only the A column has the mean, and you can do the same for B column by just changing this and then running this. Now you can see that the B column mean is 0.5, which was stored, which is the mean of the A column. So I hope you guys understand, and I think I'll stop at this much for today. So yeah, if you have any questions, anything simple, anything tough, just leave it out in the comment sections and I'll get to them. So yeah, tada.